All right, let's take a look at the ear. What we notice in the ear is that you have this external structure that's main job is to support and to localize air molecules and sound waves so they can be directed into the auricle, which then directs it downwards into the external acoustic meatus. As air molecules hit the external acoustic meatus, it's going to start to cause a vibration in the tympanic membrane. On this one, you can see the tympanic membrane right here, and you'll notice the tympanic membrane is a watertight, airtight membrane that starts to move when the actual air molecules starts to hit it. As it starts to hit it, it vibrates its tympanic membrane or eardrum, and as the vibration is carried inwards, it's going to start to be carried into the bones that are attached to it. The bones that are attached to it there's going to be 3 separate bones. The first one is attached to the tympanic membrane directly, right? And that's called the malleus. As the malleus moves, it starts to move the incus, number 4. As the incus moves, it's going to start moving the third one that's actually attached to the cochlea, and this is called the stapes. So the malleus, incus, and stapes are attached to each other. And as the tympanic membrane vibrates, so does the malleus, so does the incus, and now so does the stapes. Since the stapes is attached specifically to the cochlea then and the cells in the cochlea are going to start to move. Right? The region where the cochlea is attached to where the cochlea is attached to stapes is this membrane that is lettered A. Right? This is called the oval window. The oval window is about 50 times smaller than the tympanic membrane. And what happens is small movements of the tympanic membrane causes large movements in this, right, in this oval window. As that happens, fluid starts to move in the cochlea. The fluid then starts to bend hair cells, inner hair cells, that then starts to shake and bend and start to undergo action potentials. Depending on where we are, right, the inner hair cells are either responsible for the light, or let me rephrase that, responsible for the high pitches or the lower pitches. Right? Now on this side of the cochlea, you'll see the round window. We'll talk about the function of that coming up. Right? This whole area right here, this whole thing, it is the cochlea. Snail-shaped organ meant for hearing. Now when we look at the rest of this ear, right, you'll notice that there's an opening right here and it should be filled with air. This is your middle ear canal, should be freely movable. Within the inner ear canal, you should have this opening that connects it to the throat. This is called the eustachian tube or auditory tube. Then a muscle immediately superior to that called the tensor tympani muscle, which is number 12. The main job of the tensor tympani is that it tenses the tympanic membrane so that loud sounds does not allow us to kind of blow the eardrum.